Alright, this is old electronics fan, and this is a simple little amplifier. It's not, it's got, well, let me back up. I did something that I told myself I was not going to do, and that was to make a video about something without having first done a little bit of research on it. The reason why I didn't do it on this one was because I was doing a video on on two other stereo amplifiers. One was a transistor unit, and one was a tube unit. Both of them very low output by design. And I was looking for something to use with this. And part of what I was doing was I was showing how different amplifiers have different requirements when it comes to speakers. Vintage systems, low watt systems, don't do well when you ask them to power speakers that are designed to handle higher wattage. And what I found when I was playing around with that was get my brain in gear here. Well, it was kind of funny because I have a tube amp that dates from, let me think, maybe early mid-60s. Then I have a little stereo, the transistor amp, a realistic, inexpensive unit. That was from probably early mid-70s. The transistor amp didn't like powering the higher watt speakers very well, but you hook it up to this and it did just fine. And by the way, if you're dealing with vintage radios and you run into a distortion problem, pay attention to what you're working on, and it may not be that the unit itself really has a problem. It may simply be it doesn't like the speakers you're trying to power with it. So just don't forget that when you're dealing with some of this old stuff that's, you know, probably around 4 watts, 5 watts per channel. So anyway, so I was playing with those. I dragged this out, and I went ahead and started doing something with it, and I got into it more in depth when I was going to with the video, and then I thought I really should look for more information on this. And oh, the other reason why I didn't do this was the only information I had, AMP 59700. So I thought, I'm never going to find anything on this. And then as I went through the video and then I started sort of cleaning this up a little bit, I discovered this. There's a number on here, and you probably can't read it, so let me read it to you. It's 636182-2. So I plugged that into a search engine, and it immediately told me that it was a Magnavox amplifier. This number actually also gave me some results, but this is what I really expected to happen. There is no circuit diagram information. There's no schematic. There's basically almost no information on that. I found some of these for sale for ridiculously high prices. After getting this to work and testing it through some of my higher watt speakers, I could see somewhat why they might be able to charge the prices they were asking for these. I was really shocked. So anyway, this is a Magnavox. This is a an amplifier for a console, and if I flip it around, if I can do that without screwing anything up. Alright, so over here it says changer power. Over here it says tuner power. So this little amp was designed initially, well, it was designed with the capability of running a tuner and a changer. I don't know what they added to this to set it up for use with the tuner. Just not sure. I'm guessing. Well, let me just quickly mention. I may mention it further on in the video, so bear with me. This is designed so that power comes in, goes out through one wire, comes back on another, through this, which is hooked up to the turntable. So I'm assuming it's a similar idea with the tuner. Turn the tuner on, and since it's also a tube tuner, it would take it probably about the same amount of time to warm up as this does. With the turntable, you have to wait a minute for this to actually warm up before you can actually get anything to play. But anywho, that's the nature of tube stuff. So, so my original thought that I wasn't going to be able to find much information on it was partially true. This has no schematic information. I cannot find anything on this anywhere, and I really searched. Ooh, so my steel wool, I guess I need a different piece. It's shredding on me. So, but I did find out that it's a Magnavox and that it went to a console. So that at least gives me that much information, such as it is. And so I'm going to then now we're going to go to the video as originally recorded. I'm not sure if later on in the video I mentioned how I didn't find any information on this. If I do, and I don't edit that part out, just know that that part was recorded first, this part was recorded second, and we're going to go from there, and I guess that's it. On with the rest of the video. It's got a 12AX7, pretty common, 6BQ5 and 6BQ5, which I think those put out about 5 watts. There's your rectifier tube, a couple of output transformers. We have a electrolytic here, and it's a busy little guy. It's got 40 microfarad at 450, 30 microfarad at 450, 40 microfarad at 400, and then we've got probably a bypass cap of 40 at 25 volts. So there's a lot going on inside that little thing. Alright, so let's flip that over and see what we have got. So, and it's pretty simple, pretty basic. Power comes in here, goes through this connector. Would normally go through a switch, but the previous owner has tied together two of the wires so that it turns on when you plug it in. And you know, when I look at this, there's not a lot scary going on here. I have no idea about the electrolytic capacitor, which is right there. But a lot of disc capacitors, so this is fairly new, but you've got this guy here. Now this is filtering apparently the input, because that goes, this is the input connection here. And what's really interesting about this, and I must confess it has left me sort of scratching my head a little bit, because I'm still learning about the different ways that things can be done. What kind of the way that circuits can be wired up to accomplish whatever it is you're trying to accomplish. And what's interesting about this is you've got these controls, and I don't know if it's got a dual volume with a tone control, or I have no idea what it is. I'm betting that's what that is, but I don't know. But these two wires go into the input right here. Then these two are the inputs into the whole system, and they're wired into this. Right now I don't have anything attached to it. I do have my turntable over here set up to go, although I don't have a record on it. But that's easily fixable. I have no idea what I've got floating around. Just who knows? Let's see. I'll just throw something on there. Oops. Hopefully people don't mind a little bit of folk music. Of course, it's not going to be on very long. Good old copyright strikes. So, from what I can see, looking this over, the power supply has a center tap lead that goes to ground, so I'm going to call the chassis ground. And the other thing I want to find out, well, I want to find out two things. Does it hum? And other thing is, do I have plate voltage? And I had to look up the pins, because there is no, as far as I didn't really look for a circuit diagram. There's minimal information on this thing. The only thing I could find on here is it says amplifier and it's got a number. Chances of finding that information anywhere? Probably, well, slim and none. But for the moment, and this is just a little amp, so hopefully I can sort out what's going on. Got my meter back here, which I don't know if you can see. Yeah, I guess that's it. And so I've got my variable transformer, isolation transformer up there. Let's see here. I guess I'm ready. See what we got. So we'll turn this on. I have my lights hooked into the circuit. My 3 light setup. What's nice about that is I can select 1 bulb, or I can select 2 bulbs or 3 bulbs, whatever I want to do. And oh, and the other thing I have is a kilowatt plugged into it, so that tells me when I'm actually reading it or producing enough voltage to trigger. Alright, so my light is starting to come on. It's not coming on hard, in fact you can't see it. And my kilowatt is coming up, says it's 40, almost 40 volts. Alright. And my meter says we've got 16 volts, so right now, one of the reasons why I have my kilowatt there is because those bulbs act as resistors, and of course you're dropping voltage across them. So right now, this is, I have my transformer says I've got 75 volts on there, but that says I only have 50. Now this says I've got 57, so that's a good sign. At least the electrolytic isn't shorted in here. Is it good? I don't know. Are the tubes lighting up? Don't know that either. Let's see. Don't see any lights. Well, let's give it a little more juice. Let's see. So I'm up to 70, 80 volts there. And the voltage coming into this is 59. So my power supply is working. Now, this tube typically runs around 250 volts plate voltage. So this is probably a bit low. I've only got 59 volts going in here, so let's see. So far I don't hear any humming. 62 volts, 87 there, 66. I'd like to see 70. Typically things are going to, although I've got a light starting to get kind of bright over there. I don't see any. I do have this wired into these speakers. Let's see what we got. Still, if I have any. Alright, well let's do the next thing. I know I've got plate voltage, and while that's kind of low, let's see here. I have very slight hiss coming out of that. Now let's see here. Well, that would be interesting. I should probably check to see. Yep, I heard static. Let's see. I got one channel. only one channel. But this wire, I had to fix the ground wire on this. Maybe. Nope. Nothing. Nothing on this side. Well, interesting. Let's figure that out. Could be a dirty tube socket. But what's really fascinating is that there is no, so I've been, oh, okay. But this side doesn't have anything, so I got to figure out if it's just a bad connection going into here. We have, whoa, wow. So we have a flaky connection, maybe even short. So let's see if we can fix that before we go further. Alright, let's move this over where I didn't really look at that part. Well, ground wire. The ground looks good. That looks good. That looks good. Let's see. Yeah, and I'm pretty sure that this is wired up exactly the way I thought it was, which is that it has dual volumes and tone control. Okay, so let's yeah. Well, let's take a quick peek at this ohms wise and see what we got. Because I'm going to check these wires, make sure we have continuity. Alright, and so I'm connected to the black wire. That's good. And then we'll check our ground. And let's see. That looks fine. Alright, put it in there. Could mean it's just, oh, yeah, that was a little bit loose. I guess we have to do a little bit of persuading here. It doesn't really want to go. Really? Oh, that's too far. No? No, maybe not. Alright, now let's go with this one. Yep. We want wire. That looks okay. That looks okay. Oh, yeah, alright. Okay, we'll keep going. I gotta check the other wire, the other end of the wire too. And looks good. Alright, so this part looks good. Now I'll just check the other end. I think we have a little bit of corrosion going on, and these connections are a little bit loose. So, okay. Now, the next thing I want to check, I'll use this end. That's what I want to know. Are we good all the way through to here? So now, So gray wire is black one, so we'll go from here. Alright, black wire. That looks good. And we will around. Looks good. Go here to our red wire, which is our green. Oops. Looks good. Alright, maybe I just had dirty connections. Everything looks fine. The way it was acting, I was kind of wondering if it was shorting out or something. And alright. Okay, so back up there. Put this here. And well, I'll keep monitoring the, although the plate voltage, well, not at full volts yet, so I guess I should probably still keep an eye on that, see what it's doing. But the thing is actually doing something, which I was kind of shocked at. It's also kind of quiet, which is also surprising. All right. Let's see. Go back here, here. And well, we've got two tubes, so I should check the plate voltage on both of those, I guess. So maybe I will leave that red wire off. Check that out. Yeah, that's a 75 watt, well 73 watt bulb that's firing up right now. And if I wanted to, that's a 100 watt. Well, let me see. Let me it. Oh, that's right. 100 watt bulbs are now 73 volt, the 100 watt equivalents. And the other one was 43, but it's supposed to be 75. It's very, very confusing these days. So now that's tone control. Okay. So this one is that middle one. And we have nothing. Okay, let's go this way. Okay, so something's not happy. Let's take a quick look. Oh, well. Alright, so pin 7 is the other tube. Come on. Come on, will you stop? It's 108. And what's this one? 114. So the plate voltages are similar. I'm getting some noise, so maybe I just have a dirty socket. I haven't cleaned them yet. Nope. Oh. 12AX7. I bet that's my problem child. Let's see. Tone. Okay. Boy. Considering that I haven't done anything to this other than plug it in. This is kind of amazing. Right now, my my variable transformer is at 110. It's putting out 83 volts to this. And I'm getting 100 something volts on the plate. What I might do, well, what I think I'm going to do now is just turn this off. We're going to clean those tube sockets. Now this poor thing's been kicking around a lot, and oh yeah. Well, let's juice it a little bit and see what we got. Okay. Yeah, those aren't. One of these tubes was lying in the bottom of the box, and the pins are kind of bent. Not a big surprise there. Actually, a lot bent. I'll try to gently finagle them back. They belong. Yeah, these are definitely tweaked. I don't have a tube pin straightener. Some tube testers have those, but mine does not. So the socket doesn't look that bad. That's a lot better. Let's see how you look. Ew. Oh boy. That pin is tweaked. Oh, and there goes the tube. I just cracked it. This is what you have to be careful of. And I bet that's going to go to air. Well, I don't know if I have any of these 6BQ5s. I don't know if it went all the way through. So we'll find out in a minute. It will tell me. It'll go white. I'm going to try to fire it up. It'll smoke and do bad things. That sucks. But let's try it now again. Give it a minute. Let's see if we can give her some more volts. Oh! I have both channels now. I may have gotten away with that. You notice I'm not trying. Yes, okay. Now, okay. Okay, so I've got 90 volts. It's a bit noisy. Let's see. Oh, why don't I have two of them talking to me? I thought I had coming from both. Well, had. There's that one. I'm betting this is volume control. Nothing. Well. Well, let's see if I get one side to play at least. And let's see here. Oh. Things work better when you plug them in. Alright. Alright. So. We got one channel not working any well at all. Well, I was hoping that music might be less problematic. Okay, so this is the one, the red one. Why don't we have... Come on. Okay, well... Oh, oh, here's an interesting idea. No, I don't want to do that because if I put this in directly, I won't have any volume control. And that would not be good. It would be blasting away. Well, I guess I have to figure out what's going on here. Well, let's see. Hot. They're both the same temperature, which is a good thing. Okay. I'm going to swap these tubes just to see. Maybe I terminated that. The tube that I cracked base on still looks like it's okay because I might not have cracked it all the way through. I don't know how long it's going to survive, but let's see here. Okay. Still nothing. So what that tells me is that oh. Ground. Lousy ground. There. Alright. See, do I... Oh. Well, the same channel is still working. So, what does that mean? The problem is here. So I swapped these two. So that should mean that I'm getting signal on both of these, because the green one was here, had signal on that channel. Okay, so I've got a problem. Well, that's interesting. Oh, wait a minute.
Tell me who will sing for you.
Well, that's interesting. Both speakers are working. Both speakers are working, and is this treble and bass with one volume control? It very well could be. That's weird. Um, that's weird. Well, that is definitely weird. I gotta figure this out. I'm gonna unplug it first. Alright, at least it's not humming. Alright, this is what's in here. And I've cleaned the controls, because I could feel when I was rotating them, they were pretty gravelly. This control has a center tap. And so I automatically thought of this being a volume control. And there are two pots on here, so it very well could mean that there is just one volume control for both channels. So, treble and bass, this one doesn't seem to be doing a whole lot. Yeah, okay. So I've got a capacitor, I've got capacitors coming from this one to this control. And I've got capacitors over here coming from this control to this. But I also have capacitors across this one. Oh. Well, that's really interesting. I've not seen this before. But there's a lot of things I haven't seen before. Let's see if I can get some more light on here. I don't know what... This is more than center tap. You've got your normal volume control connections over here. And, alright. So you've got normal volume control connections over here. But you've got a pin here and a pin here on both of these. Now usually you center tap these because it's a loudness control. So does this mean they've got it heading in both directions, both when you're going on lower volume and higher volume? I don't know. But it looks like this is indeed the volume control, just one. There is no balance control, none whatsoever. Well. Okay. And I could see these capacitors over here connected to this, and I thought, yeah, okay, that's probably tone control. This one has a couple of resistors, but also has these two capacitors going over here, so this could also be a tone control. I've never seen anything done like this. I'm kind of scratching my head here. But I must confess that I haven't gotten into a variety of ways of handling tone and volume. Other than, a lot of early radios had a center tap volume control, and like I said, it was like a loudness control. Interesting. Quite fancy. I don't know, because you've got capacitors here too, tied to these. So it seems like they're shaping the sound in a couple of different ways, particularly on the volume control. Huh. Well, very interesting. What I'm going to do now is, now based on, well, I've got some hissing going on. I don't know if it's a tube or something else. Let's take a look back. Let's go back underneath and take a look. Let's see here. Which way do you want to go? Maybe this way. Maybe I need to go through and clean those sockets again. I haven't cleaned these output tubes yet. Let's drop you down there. No, I don't want to do that. Except you really can't see much that way. Let's go. Maybe flip it this way. Alright, maybe that'll do. Yeah, let's do that. Alright, well this is interesting because back here, these are the two power output tubes. That's your 12AX7. And you've got a pair of disc capacitors linking this tube to these tubes. This is your coupling capacitor. When I first started looking at this, these, you've got three wires, you've got this capacitor and these two resistors. Something had gotten in here. Oh, I don't know if you can see that. Okay, there's something I want to show you, and it's kind of a warning both to me and to you. This thing was bouncing around in that box of stuff apparently for a long time. So when I got this, I really should have checked underneath to see if everything was okay. And it's almost by accident that I discovered what I discovered. You've got this, let me back out a little bit here. You've got this resistor and this resistor, and these are the two positive input connections. This is where this control comes into the chassis. So this is an audio input, this is an audio input. When I looked underneath here, I was doing something else and I happened to spot this. This resistor, the leg of this resistor and the leg of this resistor were mashed directly together along with the capacitor. They were all just driven right into the chassis. Now this is chassis ground right here. I don't know if, are you seeing what I'm pointing to? Alright, so this is chassis ground right here, which is what this leg of this capacitor is connected to. So not only would you have these two pins shorted together through these resistors, you also would have had them both shorted to ground. This would have been a very quiet amplifier because the input would be completely shorted. Not just to itself, but to ground. And I did find other things that concern me elsewhere in this thing, which I'm pointing to and you're not even able to see it. So when you've got something like this, and hopefully I remember this, because I've run into this before, and it seems like I'm kind of dense, and I didn't get the message the first time. You see stuff like this. This thing got tossed on top of other things, and everything just got mashed down. Anything that could move got stuffed into the chassis, at least in this area. So, anywho, oh, by the way, see that? That is a balance control. If I had seen that, actually I saw it and didn't pay attention to it. If I had seen that and paid attention to it, I would have realized that there couldn't be two volume controls. I mean, there were other indicators that should have told me that, but I would have known that I couldn't have two volume controls because here's your balance control right here. So I was being more than a little bit dense. I really need to stop and think about the things I'm finding. Now, let me back up. I suppose it's possible, and I'm trying to remember how some other stereos are done. I suppose it's possible to have a balance control remotely, and then you have a control here to try to center or balance the voltages on for the different tubes to try to get the left and right channels equal. But I don't believe that's what this is doing. This, because I think one leg of this goes over to I bet that's a. Let me just see. Okay, so this is a grid, and this is a grid, and this goes to. Looks like we have a whole. This is very interesting. Let me back up before I get into that. I may have to look up that and see what this is. Actually, I'm going to do it right now. My 12AX7. Maybe one of these days, if I keep doing this, I'll know just at a glance. Oh yeah, that's this pin and that's that. You'll know what's what. All right, 12AX7. 12AX7. Where are you? This is an extremely handy book. This is my dad's book. He used to tinker with electronics too. 12AX7. So pin is. All right. So one side, 2 should be a grid. Pin 2, that's grid 2, okay. And grid 1 is pin 7. Pin 7. So let's see, yes. Alright, that is correct. So this is one input. This goes to pin 7, which is a grid. And this one goes to pin 2, which is also a grid. Makes sense. But now the question is, what is this? What is this actually doing? How is it balancing the volume, on each channel? Trying to make the channels equal. So this would be pin 3. So pin 3. See, I'm still learning stuff, and I anytime I get a chance to learn something, I take it. Oh, cathode. So pin 3 is a cathode, and pin 8 is a cathode. So what it's doing, that's very interesting. I definitely got to study some more theory. But what this is doing is it's balancing the two cathodes. This resistor sits between the two cathodes, and when you turn this control, you're changing, I guess, the bias or the voltage that's showing up on the cathode. Very interesting. In order to get a circuit diagram for this, I'm going to have to make one. And the more I play with this, the more I want to draw a circuit diagram for this, because it's going to be part of me teaching myself how things are wired, how electronic engineers do things, and I really do want to learn more about that. And there are some people out there who have YouTube channels who just, they know the theory, they look at a circuit and they know how it's supposed to work. I am not one of those, and I want to be a lot better at that than I am now. So anyway, if I want a balance control, I can give myself one by mounting a remote control. I'll have to measure this and see what the actual resistance is, but because I have a feeling it's probably kind of important to get this close, because you're dealing with the voltages on the cathodes of the triodes that make up the 12AX7. And so you really don't want to tinker with that too much. They've chosen this value on purpose. There are other places where it doesn't matter as much, but I think in this case it does matter probably a bit. Not that it wouldn't work. So if this was, say this is a 2 meg ohm, if you put a 3 meg ohm in here, that might work. I'm not sure I'd want to put a 1 meg ohm in there. I don't know. I don't know what voltages are on the cathodes. Without having a diagram in front of me, I'm not exactly sure of what they're doing, and I do think I want to find that out. So if I do that, I may post my homemade schematic for this little amplifier over on the Radio Museum site. And if I do, I might go back and put that information in the post it in a pinned comment for this video for anybody who might be interested in that. Of course, the voltages are going to have to be whatever I can read out of this thing, which won't necessarily reflect what the original design and original schematic was giving me. But I'm going to go through and I'm going to check all the resistors and replace any of these that are out of spec. I'm going to check all of these capacitors because these can go bad. And now I'm trying to figure out what's going on here, and it kind of looks like, well, let me go back to here. This is tied into this, and it, oh, I know what this is. I know what this is. This is a, what? They've got a capacitor in here that I thought was the bypass capacitor for these, but there's another capacitor over here. I think it's a 2 microfarad. And this is tied into the cathode as well. I definitely want to know what's going on here, because that doesn't add up to me at all. Interesting. Well, anyway, I digress. I definitely want to test this, though, because this can raise Cain with things if it's not right, if it's not healthy. So I'll be testing this. I'll be going through this to make sure everything is right. And once I do that, I'm going to go through it and I'm going to draw up a schematic on this, because number one, it's going to help me if I have problems with this in the future. I'll have something that will help me. Plus, once I know that it's working properly, I'll have voltages, and I will be checking voltages throughout this to give myself an idea of what healthy is. But anyway, so I don't even know where I was going because I got too carried away. But anyway, the lesson I want to walk away from this with is look underneath your device, whatever it might be, especially if it's been floating loose and not in the case. Just make sure, and actually even things that have been in the case, I've run into those where they've been taken out and put back in, and they've been, you don't know what happened to them while they were floating around loose outside of the case. And I've run into this kind of stuff with some of those things as well. So it probably makes good sense to, when you get something, I'm talking to myself right now too, to do a quick examination of the underside of this thing, your device, whatever it might be, and look for stuff, because these things, you could have had fun trying to track down why. Well, I say it could have been, well, let me back up. If you did any troubleshooting at all, and you looked underneath at all, you would have spotted this, and it would have been fairly straightforward to discover what was wrong. However, if you were trying to troubleshoot it from above, and you never looked underneath, you're going to be pretty puzzled up until the point when you measured across these connections and discovered that they were shorted, and you would find that out. And then you look underneath, then you would know why. Anyway, okay, let's move on. What's also interesting is they've got these two wires. I was going to look at that further too. Got these two wires which are not identified in any way. Whoops. Alright. Got these two wires which are not identified in any way. I taped them off because I did find out that one is a speaker connection and one is a ground. And because if you go over here, you see this wire going over here and comes to connects, and it comes and connects to it comes to this wire, which which that wire goes over there to one of the speakers. Then you've got this other wire coming over here. So you've got these two speaker wires, and only one of them comes out here to this. Why don't you want stereo? Why wouldn't there be a third wire here? I don't know. I guess if you wanted that, you could run your own wire, but why didn't they? And it doesn't look like they actually did. I'm looking, because this is one speaker connection here, and this is the other speaker connection here. And you can see where they ran this wire right in there and soldered it in. This green one right here, which goes over here and out here to my hand. But this one, this wire goes over here and goes where that belongs to the speaker connection. It's back here, and this is the transformer coming in here, and this is a little resistor feeding who knows what. I haven't really sat down to try to figure out how this thing is wired. My initial goal was simply, does this thing work? And it looks like it does. Although, like I said, it seems to be a bit noisy. Interesting. I'm learning more and more that electronics engineers have some very creative ways of doing things. And I'll never forget, I was troubleshooting something, and I was following the schematic and trying to follow the wiring in. It was a piece of test equipment, I think. And I couldn't for the life of me figure out if the schematic matched the device completely or not. So I sat down and I actually started drawing my own schematic to try to make sense of the thing. And when I got part way through that process and I started comparing the two, I saw what they had done. I drew the schematic, my schematic, the way it was wired up in the set. It made sense. They had done some rather unique things. Connections, all the connections were right, but they were drawn quite a bit differently in the schematic in terms of where they went and how they got connected and all that stuff. So I felt a little bit silly because I didn't, I couldn't read the schematic and figure out that, yeah, indeed, it does match the device. The schematic was correct. Far too often I'll check things out and discover that the schematics do not match what you're working on. And that's not entirely unexpected. Companies will build something and then they will discover a problem, or they want to make an improvement, so they modified the wiring, changed the schematic, and depending on your sources, you may get a newer version of the schematic or an older version. And sometimes you can't find the older versions. So it gets really interesting at times. So, and this leads me to a thought that I just want to pass on. I've seen people start rewiring their radio, their amplifier, or whatever, based on what the schematic says it should be. I'm a bit reluctant to do that because I don't know whether I would be improving. Now, maybe if I had enough theory under my belt, I would be able to see, oh yeah, I can see why this is different, and yeah, it's a better change, or it's not a better change. And I'd be able to go through and say, oh yeah, let's do it this way or do it that way. In fact, Radio, TV, Phone on It just did that with a radio that somebody had cobbed to death, and it didn't have a schematic diagram, but because he knew circuits very well and knew the theory extremely well, he was able to go through and start rewiring things without a schematic, and he made the radio work quite well. I am not in that same league, not even close. So, after all that, so this is definitely going to be interesting. It may inspire me to start exploring tone circuits and different ways those can be wired up. And I have actually looked at some of that, and they are very interesting because you can have a variety of different ways of handling tone control. And that's what we're basically dealing with here with this crazy setup. Okay, I've gone through, I've cleaned the tube sockets. I'm going to fire this thing up. I'm betting it won't make any difference in how much noise I've got. Now, maybe I've got a noisy tube, I'm not sure. Given the age of this thing, who knows? Alright, so I want to check. We'll just do a quick check and see what the, oh man, this poor thing's been beat. The sides of this thing have been pounded in. I don't know if somebody did that on purpose to make it fit somewhere, or if it just, that's the kind of abuse this poor thing has had. I don't know. It's had a rough life. So now, I want to just see, pin 7 I said, right, for my plate? Yes. Pin 7. Okay, and then pin 7. Alright, so what I'm going to do now is I'm going to flip this off. So right now I've got 104 volts. Definitely noisy. Let's see what we got here. Pin 7, 236, 244. Okay, that falls within the realm of what it's supposed to be running at, and we're running at 115. Let's bump it up a little bit. So that's what that says. Let's see if, let's see if my kilowatts being honest with me. Let's see, that's going to be DC, I want AC. $122. Well, my kilowatt isn't exactly accurate, is it? Interesting. Nice to be nice. Something nice to know. All right, so 119.9. That's 120. I know it doesn't have to be exact, but I was just curious. So that means that my kilowatt. Of course, maybe I should hook it up or plug it in directly into something else. See if something's messing with the voltage. Well, no, it wouldn't be because I wouldn't have it here. Well, I don't know. All right, so now uh-oh. I see smoke coming out of that tube. I bet you it's dying. Yep. Yeah, I have a feeling that that crack really did go all the way through. Well, if that's leaking air in there, pretty soon that filament will die, which I don't really want to see it do. Well, okay. That's this is a different album I put on here. Let's see, what do I want to do? Oh, no, I didn't want to do that. Okay, let's do this. Well, that sounds very good. This little amp puts out some power. Might be a bit noisy, and I don't dare leave it on any longer. That may be too long, actually. Well, other than the fact that it's got some hiss, this little amp works pretty good. And yes, it is. This is this is treble and bass, I think, and then this is volume. And I guess if I really wanted to, and I do have another control floating around that I could probably use for that purpose, I could get rid of this balance control and have another control for balance if I decided to use this. Because what I'm toying with is um, I always get ahead of the words. My brain just jumps over to the next thought. All right, back up, reset, restate. I bought a KLH turntable with its own power supply in it, and we'll shut you off because you're noisy. Um, and I fixed it up. And it works okay. Uh, it's a nice. It's actually quite a nice little unit, but it looks like the cartridge in that thing is pretty tired. And I don't know if it's the cartridge itself or if it's the needle. It's a Pickering cartridge, and I'll have to investigate that and see, first of all, what it would cost me to get another needle. Because it tends to, on high frequencies, you can hear some distortion that doesn't sound like it's amplifier. It sounds like it's more from mechanical, something mechanical like the needle or the cartridge of the turntable, of the tone arm. So, so I've got this record player changer working, and I had other plans for this, but you know what? I've got this little amplifier which actually works surprisingly well. And you know what I'm going to do? Oh yes, oh yes. We are going to see how this sounds going through those. I'll bet this thing could drive those just fine. Because I think these, the output tubes in this thing are not high powered, but they're probably around 5 watts. Actually, let me look this up because I want to know. 6BQ, 6BQ, 6BQ. Alright, 6BQ5, I believe. Yes, it is. Output. Ooh. Oh. Wow. Maximum signal power output, 11 watts. That's interesting. Because that little Morse radio with phono, that was about 2 watts. My transistor stereo that I had, the holistic that I had up here, I guess I'm guessing that might be 4 watts. It doesn't sound like this does. This can, wow. And they've got 2 different columns. 11 watts and 17 watts. This is at 250 volts plate, and this is 300. So grid 2 and the plate and grid 2 both are at 250, you get 11. If you're running at 300, you get 17. So this is running at 250, based on what I just measured. And so I would say that has 11 watts. Interesting. This little amp puts out a whole lot more power than I thought. Because out of that, little stereo amp with just a single-ended outlet, just a single tube outlet, not push-pull. Yeah. Well, all right. So let me do what I was going to do, which is we are going to hook this up to those other speakers. I think it will drive those just fine. Let's see, red and silver. This project was way down my list of things to tackle until today. Until I got kind of interested. Oh, I don't want both of those. I want, there it is. We have Sounds of Life. Alright, so. Wow. I'm sure I left that playing far too long. Well, yeah, this little amp puts out quite nicely. surprise, this was not what I expected. I keep expecting this tube to go white, and if it does do that, I'm killing the power immediately, because that would be bad. But I don't see anything going on. Maybe I got lucky. Of course, I may start looking for, either in my stash or looking for a replacement, just because. And there is some hissing going on, but on these speakers it doesn't seem bad. I'm kind of amazed. So, so what that means is I could set this turntable up in place of the other one, throw this into a little box with the controls in it, maybe even give myself a tone control to go with it, or balance control, and this, at least for now, could replace my other unit. Okay, update. I know why this is here now. All that hissing that you heard, it's gone. I turned this all the way down, and no hiss. This was a shield protecting these controls in there, and it was there to get rid of noise and hiss. This thing is quiet. I mean, there's still a little tiny bit, but I mean, I can go all the way up to full volume, and there's nothing. I may still have a noisy tube somewhere because I hear a little tiny bit of it, but the minute I put this, I got brave. I put this on while I was playing, and the minute I did that, I heard an immediate decrease in the noise. Not what I was expecting. So, I learned something else. I mean, yeah, I know about shielding. All these wires are shielded, but apparently, this little shield cover matters. Well, anyway, that's enough for now. Okay, well, I've gone through this. I did repack the electrolytic capacitor, and I tested it beforehand, and it didn't test horrible. It did have some leakage. On one of the testers, one of the sections tested at the picofarad level instead of the microfarad level, which wasn't that great. And on my Heathkit tester, it had a power factor of 10 or greater on some of the sections, which is not great either. Plus, it seemed like when I was playing the little amp for a while, it got kind of warm. Of course, sitting right next to it is the rectifier tube, which throws a fair amount of heat, so could have been that, maybe. But I'm glad this was not a high count device, because almost half of the resistors in this thing got replaced. They were out of spec, some of them quite a bit. And usually these style resistors are pretty good, but not in this. What kind of blew my mind is that all of these capacitors test like brand new. There's no hint that these things have been used for however many years this has been. The brand on these is Goodall. Interesting the way they're made. The outside of this seems to be completely molded. And there's no shell or anything. It's just the capacitor is made, and then they put this in the mold and just mold the plastic all around it. And these some kind of ragged edges on one end where this sticks up out of the mold, but or sticks where the open end of the mold is. But they seem to be pretty solid, pretty amazing. Oh, this, by the way, I called this a 2 microfarad capacitor. It went over here. It's actually a 20 microfarad capacitor. And as you can see, I'll drop this down actually, This is the replacement. This is a 22 microfarad at 25 volts. So it's slightly higher microfarads. And when you compare the two, whoa! I knew that they'd gotten smaller, but that was just crazy. So I haven't put the tubes in this yet. I didn't want to have them in it while I was working on it. I have one tube that's, we don't know how long it's destined to live. We don't want to kill it sooner than it has to be by banging it and finishing the job of cracking the base that I started. So let's throw some tubes in here, and let's see. Yeah. Okay. Oh, this is the one that cracked. Oh, all right. Well. All right. And we'll put you in. And so far, that tube has survived. If a tube goes to air, you really don't want to run it for very long. Well, it will definitely fry the filament, but there are other things that are not so great that happen when they start acting up. I think they can draw more current and stuff. I forget. I just remember that it's not ideal to keep playing something when you've got a tube that has gone to air. Let's see. This, oh, come back here. Is going back in here. Oh, don't follow up on me. And we are going to start it off again with the variable transformer. Whoops. Come on. There we go. I'm not exactly sure why they did this. I'm not exactly certain if these were stuffed into something, and I just don't know. I have no idea. As I mentioned earlier, and I'm repeating myself, there is almost no information on this. Now, one of these amps that is a similar type of amp, I mean, it looks like it's twin, but it's got a different number on it. It's 192, I think, instead of the 597. For that one, they list a console that it was used in. This one, I can't really find much information on it. I'm kind of surprised. Okay, so I think I'm ready. Oh, one of the other things I did was I took this wire out of there. I took that resistor out of there, which probably means, well, I'm going to put this back in the center, see how that works. And I think, I'm going to use this with a turntable. I've got to have something on the turntable. What do we got? Let's see. Guess we will look at what we got here. I don't know. For some of you, this might bring back some memories. Let's see. Let's see. Well, we'll try this one. And I'll leave that as is. And that's plugged in. This has got to be turned down. And go up on our volts. Let's see. Let me back this out a little bit. And hiding over here are our lights. And let's see. There we got. Not my. Okay, so I'm really low on volts. So let's put this up 2 voltage again. Where are you? All right. Well, let's start over. All right. Reset. 37 volts. So we have to go up a bit before anything starts happening. And I'm going to do that. Okay. let's see. I was able to get this little clip out of here. I tried it because it's definitely going to make things easier. It was either that or unsolder some wires, and I didn't want to do that. Okay. Don't seem to be having any voltage. Did I plug in the right cord? I did. This is okay, looks like. Is that okay? Well, let's find out what we got going on, because I don't seem to have much here. I should have some activity going on. Come on, you. So I really shouldn't wind my cord around my stand. Let's go. Alright, I thought this would be just simple. Turn it on, test it, and then move on. 20, okay, so, let's start with this. 65 volts. And okay, so that's one leg of the transformer, and that's the other leg, and I've got 65 volts, 66 volts. Alright, I should have 6 volts here. I think that's DC. Nothing. No DC volts. Well, that's interesting. Huh. My lights aren't lighting up. I know my voltages are low, so let's see. Let's see what we got here. Oh, it helps if I put in the right volts, the right setting. Right, 75 volts. That should. Well, maybe it is. Okay, there it is. 4 volts. All right. I was working with battery-powered radios and got used to the filaments being DC, but that's not the case here. If I thought about it for a minute, I know that this has a winding for the filaments, and I don't seem to have any filament action going on here. Huh. Let's see, my 4 and 5 are the filaments on the SBQ5s. Pretty sure this was playing when the voltage was this low before. 4 and 5 right there. 3 volts, okay. Let's turn it up some more. And oh, there we go, I get a little light action. And let's see, right here, 0.3. Oh yes, now they're lighting. I just didn't have enough volts. And apparently my light bulb is why. Okay. Let's see. Ooh. Okay. I think. Now, you might be able to see that light bulb back there. And I'm going to crank this up a little bit more. And a little bit more. And this is my 100 watt equivalent. It says 72 watts and 1490 lumens. I believe that's the 100 watt bulb. And one thing you may not have heard this on the previous section. and the camera may not have picked it up, but there was some static and some noise in this thing. And part of it was because I didn't have this on. This little, this case around the volt controls. Without this case, which acts as a shield apparently, things can get a bit noisy. But even so, it seems like this is a whole lot quieter than it was. I can max this out, and I just hear a slight hum. Oh, and you can't see a thing because I'm not aimed at me. Alright, so this, I can run this up to max and just hear a slight hum. And I think, though, well, let's just check. Let's go here, and I want to check the plates on my 7 and ground. Alright, pin 7. Alright, pin 7. 7. Is that right? 6. Oh, that's 1. Alright, this is, oh, I see. Alright. Alright, so I've got 118. I'm going to go full power, and we'll see what we've got. So I'm curious to see, if replacing the electrolytics made a difference in the plate voltage. Actually, at the moment, no. So this says 120, and that's probably going to lie to me and tell me, well, the kilowatt is probably going to lie to me. Let's see, though, I'm just curious here. Yeah, 120. Alright, so we're there. So let's check out our plate voltage. I think this is our V plus voltage, 260. I did not check this last time, I should have, but okay. But let's check this out. That's 250, alright, okay. So it warmed up, and yet, so the voltages are higher. Because they were around 244, 238, somewhere in that range. And now, the plate voltage is reading what you would expect for this, for these tubes. The, I say expect. The tube manual mentions running these tubes at 250 volts or 300 volts. And it's 11 watts or 17 watts, depending on how you do that. And so the fact that these are running at 250, and they were at 244, 238, depending on which tube you tested, that means that my B plus is a lot healthier. Now let's see. Okay, volume's down. Uh-oh. And we don't have anything. Oh, you know why? I know why. I also know why I have a hum. The input needs to be connected to an output if you are indeed going to hear it. Let's try this again. Aha, there we go. I don't know if you can hear on the camera the nice bottom end coming out of those Scott speakers. But this thing sounds really nice. So I think I'm done with this. I think I mentioned somewhere, yeah, I did at the very beginning of this video when I reshot the beginning part. I mentioned the fact, whoa, those output tubes throw a lot of heat. I won't need a heater down here in my man cave with those things running. They're throwing a good amount of heat. I was saying something. Oh yes, I mentioned that I wasn't intending to do anything with this. Well, I want to test this out because this was low on my priority list until I got playing with those other stereos and wasn't entirely thrilled with what I was getting out of those for sound. What I was doing there was this piece. I mentioned that this poor thing was bouncing around for quite a while. So I took some of the silicone chew and just spread it across the edge of here so I could pull this back up and secure it. And it looks like it did the job. It's solid now. The reason I was worried about that, because you lift this up and the wires are right there. I'm really happy that nothing hard scraped the insulation off from the wires. They look like they were in good shape, except for the fact that this thing was flopping off, and I just really didn't want it to stay that way. So I think I'm going to wrap this up here. This little rascal was, well, it shocked me. I didn't expect much from this. I just grabbed it on a whim and said, well, I'm going to play with this and see how far it gets me, and to see what it is, because I really didn't know exactly. At one point I thought this was something commercial, like it was part of a jukebox or something, but there were things that led me to believe, these controls for one, that led me to believe that that was not the case. And it's similar because I also have a Seeberg amplifier that I'll be working on at some point. That definitely shows that it's a commercial device, and it's interesting how the Seeberg was designed, because part of the power supply is separate from the amp. And somebody who decided they wanted this to be a standalone amp added a transformer to the chassis of that amp. I think the supply is 6 volts, because the way it was wired indicated that was not originally, the 6 volts was not coming from anything on the chassis. It was some other source within the jukebox. But anyway, I am wandering far afield. So what I'm going to do is I'm going to play with this and see how it behaves. And if it behaves as well as I think it is going to, then this is going to go into service. I'm going to use this. And I'm going to use that turntable that I think I finally got working. I may do a short video on that, because this is my first turntable that I've refurbished, and there were some things I ran into that, knowing what I know now, I would do things differently, because there are certain things within the turntable that don't want lubrication, and I went ahead and lubricated everything. And it turns out it was a mistake. So, that may be just a short little video. Hopefully it's something that will help people who are dealing with these old BSRs. Whatever information I can hand out, that's my goal. Alright, so, enough yammering. I hope that you've watched this far. If you have, thank you, and hopefully I'll catch you on the next video. Thanks for watching.